So now I have 23 minutes to present. So I said the site was once like this, but now it's like this. Because I don't know. The site is being used for religious purposes. People, they go there, to pray. The community also use the site for rituals and whatnot. So they lit fires, which then disturb the art. We have a very thick soot which is compacted on the walls. So the art is behind that thick layer of soot and dust. The last time we were there, that is in 2023. I first recorded the site in 2019. Then in 2023, I visited again. And I was asking them, where do we find panels of art here? And they don't even know if there is rock art there, meaning what they use the site for is different with what we are trying to protect. So I had to ask myself, we are doing the conservation for who? Because to them it's not even relevant. So in 2019, we divided the site into 5 galleries, recording the extent of the damage, using the condition assessment done by Pascal Tariringa in 2001. Comparing the two condition assessments, would see that the site was deteriorating at a very, very, very fast rate. So we noticed that there was agents of deterioration like soot. There was loose dust as well. There was a combination of both soot and dust. These are some of the recording forms we were using. So we became very ambitious and say, isn't it possible to remove this and dust? So we didn't go to do it on the site. We're doing it in the lab, experimenting with what works and what doesn't work. So working with the chemistry department at the University of Zimbabwe, with no sophisticated equipment, we just characterized components of soot and dust using literature. Also characterized components of the rock art using literature as well to say, okay, in rock art possibly you find hematite, you would find manganese. In soot possibly you'll find carbon. In dust you'd find silica. So considering that, they proposed 8 solvents, mostly non-organic solvents that can dissolve carbon and soot without dissolving hematite, without dissolving manganese and whatnot. So we're working with this motto which say like dissolve like. So we have polar solvents, we have non-polar solvents, right? So polar solvents dissolve polar components. So for example, soot is non-polar, so it dissolved by a non-polar solvent. So that's how we say, okay, so for non-polar, if we are aiming for carbon and soot, we use non-polar, since hematite mostly is polar, you see. With that, we say solvents dissolve polar compounds, non-polar compounds dissolve non-polar compounds. So this is the key to the selective cleaning. Then soot is primarily carbon. So carbon is likely non-polar and should theoretically dissolve in non-polar solvents like hexane. Then, for example, hematite is polar, so it won't be dissolved by something which is non-polar. So these were the proposed solvents. We had distilled water, which is the baseline and current method being used by the National Museum and Monuments to clean graffiti. We had 5% of acetic acid. We had sodium hypochlorite, acetone, hexane, and you can see the list. Okay, before I go here. So what we did is we collected samples of soot and dust at the site. So we would put the solvent in a test tube and a measured quantity of soot. And I would measure the rate at which the soot was dissolved. So we gave it 24 hours to say, is the solvent dissolving carbon and at what rate? So after, we would dry the remaining components of the soot and measure again to see what percentage was dissolved. So these were the results. So sodium bicarbonate was the most effective one, followed by acetic acid. And sodium amyl chloride, distilled water was also very good. But the most organic ones, the non-polar ones, were not very effective as we hoped. We hoped that Xane would be the very effective one, but it wasn't. As you can see, it had 33%. So yeah, so it failed to dissolve the complex mineralized ash crash, proving that the soot is not simple loose carbon. Then acetic acid was very efficient but prohibited because the acidity attacks the hematite pigment as well. Then methanol is it doesn't know what it wants. It is half non-polar or polar, so it's in between. So it creates a risk of smearing contaminants deeper into the rock. Then our most effective one, which is, like I said, carbon is non-polar, right? It can be dissolved by a non-polar solvent. Surprisingly, bicarbonate is not non-polar, it's polar, but it was able to dissolve a carbon. And the justification is the pH balance. It's a mild alkali, and it ensures stability of the acid sensitivity hematite pigments. So how did it function? The chemical itself, it emulsifies the grease components of the soot, making them soluble in water. Then when they are partially dissolved, the crystals act as a gentle abrasive scoring agent to physically lift the compact crust without damaging the rock substrate. So we realized that bicarbonate was the most effective one, and it also has its own issues. So now we are in a process of developing a customized one, a customized solvent, considering the limitations of all the solvents. So we proposed 2 techniques in creating the customized one of separation versus extraction. So with the separation, we're just saying we dissolve everything. Then after we dissolve everything, we separate, which won't work with rock art. But extraction, we chose this one because we would use 2 solvents, a polar one and a non-polar solvent. So this forces the non-polar soot. If you use water and hexane, so water is polar, hexane is non-polar. And when you mix the 2, it forces the less dense compound to be on the top and the denser one to be on the bottom. In this case, carbon will be the less denser one, so it will be on the top using hexane, keeping the surface safe. So that was the extraction method. So in this case, the step 1 was to prepare the solution of distilled water and sodium bicarbonate, then apply the sample, then add hexane, that is the non-polar one. Then the non-polar soot dissolves into the floating hexane, it will burn the surface. Then you can extract what you don't want and leave what you want. So that the art polar pigments remain safely on the subject, resisting the non-polar solvent. In short, do not try this at home or at school. So do not attempt to do this at home because we didn't do this on site as well. We're doing this in lab. We're just playing with chemicals and see what works and what doesn't work. So there's need for precise chemical knowledge, rigorous chemical mapping, and controlled temperature and timing. Then so it's still work under progress, it's work in progress. But we don't know if we're going to recommend it because we need to consider that contaminants vary significantly across the cave, not only on the cave, across sites as well, right? And sodium bicarbonate is slow in acting, which may be challenging for large-scale application. Then initial tests were small-scale immersion studies, so it was just an experiment at the lab. Then for the way forward, we propose this is no longer a national monument. Since the art is behind the layers of soot, we wish that there will be use of sophisticated equipments for the characterization of the pigment, for the characterization of soot and dust as well. So from here, I'm going to take a diversion, a small diversion from what I've been talking about, but still it's the same thing. At the end of the day, we say we haven't tested the solvent at the site yet, but we have a solvent that can clean carbon, right? So at the University of Zimbabwe, we have a thing which is called Education 5.0, where they say knowledge should be translational by saying knowledge should produce product that is goods and services. So in short, we can say our bottle of a solvent which can remove carbon. So these are some of the startup companies which were introduced through the Education 5.0 agenda at the University of Zimbabwe. The House of Slanga deals with lotions. Yeah, their motto, they say, what you put on the skin should be good enough to be eaten. Then Robustos, they deal with oils, then use it. They deal with the solvent that I'm working on. They develop cleaning agencies like sanitizers, toilet cleaners, and whatnot. So this project is also under Use It. So this is the innovation transfer. So that's the rigorous science used to save ancient art can be translated into a commercial product. So an eco-friendly heritage science-derived detergent. So the education is also heritage-based as well. So that's it for the cleaning of fireplaces and so forth. Thank you.
Thank you very much for that presentation. You actually still had a few minutes left. You did not need to rush, but do we have any questions for Welcome regarding his topic?
Thank you very much for a very interesting presentation. I just wanted to find out, you said that the site is no longer a national monument. Was it deregistered mainly because of graffiti? And if it is so, actually, in my opinion, is that this is still a very important site in terms of its spiritual significance. And was there no a way just to sort of change the reason for the declaration of protection, just to change the narrative to say it's no longer perhaps an important archaeological site, but it still remain relevant in terms of its role, obviously seeing that there are still practices and the site is still highly used even in the contemporary era.
this question is for you, Mr. Kelvin. I give you the mic.
Sorry, do you mind repeating? I was busy going through my monuments list to verify what he was saying, so I didn't get part of the question. Yeah.
The site was deregistered mainly because of the graffiti. And I'm saying that this site, as per his presentation, seems to really also retain its relevance in terms of its spiritual significance. Couldn't the regulatory authority consider rather changing the reason for the declaration from an archaeological space or site to a site of spiritual importance? And also for the other question that I had, is this also a trend in terms of graffiti in other rock art sites, or was it only with reference to this specific one?
Maybe according to my monument list here, the site is still there. It's still listed. It's monument number 21. So it's still useful, but like the other presentations that were given in the morning, we still have that battle between, the use of sites in the modern religious, with the religious churches, and our modern conservation practices. There's always that fight which we haven't managed to find each other with these local communities. And it's one of the results of having that site almost 100% obliterated.
All right, thank you for the presentation. I have two questions. The first one, maybe I should give some context. I was fortunate, I visited the cave in 2016, and we were together with Dr. Nsila Namo. So we had a rock art workshop there. And at the time, the art had not disappeared yet, but it was very faint, and we saw some of the religious groups coming to the site to their rituals. And there were efforts to discourage people from making fires there and so forth. I just wanted to find out what are some of the challenges that you faced, because now you are saying it's completely dark, in terms of trying to explain the importance of the site to the community members, and why was why were they not listening to that? And then the second question is on the solvent that will be able to be used. I just wanted to find out if there is any known information if this solvent is going to affect the lifespan of the art itself once the tooth and the dust has been removed. Yeah.
Okay, so I will start with the last one because I'm more related to the last one. So, like I said, we didn't do the experiments on this side, but I created my own stickments, my own paintings using documented or ethnographic data about the ingredients, about the paintings. So I painted my own on rock art slabs and applied the solvent on it to see if it's going to remove it. At that time, I didn't. So we still have them in our workroom, monitoring them if there's going to be any change in the near future. Then for the first one, I think I was supposed to answer, but I'll answer. The site is being used by those religious groups as well. And like I said, they don't even know that there is rock art. What they are coming for is the mountain and the cave. We also have other sites like that. Ngoma Kurira, people they visited just for the mountain and the cave. for religious purposes. They don't even care. They don't even know that there is rock art.
Yeah, thank you. Yeah, I'm still coming from their own communities can be manager's nightmare. Now you have developed what sounds like a brilliant solution to a problem. What can be done, or what I don't hear anything about addressing the root cause of the problem, which is how communities are using these heritage sites, say as heritage managers, are destructive ways, as it were. So it's all okay, chemical, that's fine. But what about if you want socio-religious or whatever?
That's actually a separate paper we are doing with Mr. Mapiti to establish the values that people attach to these heritage places. To say, when people are utilizing the cave or the mountains, comparing the contemporary societies and the Zen hunter-gatherers, what is in the mountains where they choose to say, okay, I'm going to paint here, and someone say, I'm going to worship here, right? So it's the issues of places and sites, which was talked about this at the time. So it's a work in progress as well to say, okay, how can you deal with it? Not compromising values that people put to these heritage resources.
I think the last speaker sort of covered what I was going to say. But first, I'm not from a rock art background, so I was actually quite surprised to hear that you don't actually have the technology for removing soot if you wanted to yet. But yeah, I would just wonder, what is the value of doing this if you're not going to address? Because what, are you going to clean the rock, and then the people are going to carry on and have make their fires and have say that, you know, it's just going to be back to square one again. So you're saying, no, there is actually a project going on, speaking to the people about, yeah. That'll be interesting to see in the future what the outcome is.
Are there any last questions?
Thank you, Mr. Takunda, for a very informative presentation. I'm actually comfortable with the materials you used, but I'm wondering if, while you actually prepared the solvent, you considered the reaction of your substrate, because even though I haven't actually dealt in researching on how the rock would react to certain solvents. So have you considered how the rock would react, maybe even not after some months or after some few years, but in a long run, because your substrate is quite vulnerable, because it also ages and it tends to react when it gets in contact with certain solvents. Thank you very much.
So in considering that, that's why I said we collected slabs in the area, like granite slabs. Then we painted on them. We applied the solvent, trying to remove the painting, which they didn't. And we are keeping them. Now it's 6 years with them in the workroom, monitoring them if there is any change on the art or on the rock substrate.
Yeah, I think mine is on the first part of the presentation on the site use. Working at a heritage institution in Zambia, I find such problems quite common for sites which are very close to a community or an urban center. We have one such site, but then for us, what happened was that the same groups, because I visited this site which he was presenting in 2007, and it's surprising to see that up to now, the same trend is continuing. But for us at our sites, we basically have staff poor control in terms of where people should be, where people should light fire and things like that, not knowing what National Monuments of Zimbabwe is doing for such a site. But then we had to, looking at how big the hill or the mountain was, we had just to change and take them to a certain portion, because we know that the effect of what they are doing there won't affect the rock art which is there. So, because from what you are trying to do, even if you cleaned again tomorrow, it's back to square one. So I think now it's to the heritage managers of the site to put in place measures. I know, the groups are big really when you get there. So if that continues, it means eventually we just lose the rock art which is there. Thank you.
Thank you. We'll take one last question.
Hi, thank you for your presentation and welcome. I wanted to make a suggestion and also ask. My suggestion was going to be, instead of leaving the samples, as you said, that you had already cleaned in the workroom, perhaps it might be better to leave them outside where they can undergo the fluctuation of temperature and relative humidity. And the suggestion would be, if you know the range of temperature or humidity fluctuation, perhaps that happens within the context of within the shelter that exists in reality. Perhaps it would be good to also, if you have access to an oven, fluctuate the temperature at that range to see to what extent fluctuation in relative humidity and temperature might impact the concoction that you've made on the rock itself, and perhaps also looking a little bit at porosity, mineralogical composition might make you feel a little bit more, might aid in the study, but perhaps you've already done that. Thank you, it was very interesting.